All right, let's talk about random variables in statistics. What is the variable? Well, a variable is anything that is not a constant, right? Which is pretty much everything in your life, right? Except that the taxes. Um, so in statistics, a random variable assigns a number to each outcome of a random circumstance, or equivalently, a random variable assigns a number to each unit in a population. What does this mean, right? So for example, if I have if I write something like capital P and then parenthesis x is greater or equal to 4. Let me write x in blue. Then x is considered a random variable, like this right here. This is a random variable. It's something that being assigned to an outcome, right? So for example, we can assign x as the number of glasses of water that a randomly selected person drink daily, right? Or we can say x is the number of hours you spend studying statistics on average daily. Right, good for you, right? You spend more than 4 hours studying statistics each day. There are two broad classes of quantitative random variable. Notice that I say quantitative because there's another random variable called qualitative, which is categorical. But here we talk about quantitative random variables. That is, that are discrete random variables and continuous random variable. So for the basic stat class, the first distribution that they introduce for discrete random variable is binomial distribution. So binomial distribution is a discrete random variable. Distribution. I didn't have enough space to write. And then for continuous random variable, the two distribution that we're gonna dive in today is, or maybe in the future, is uniform distribution. Uniform, that's U. Uniform distribution and normal distribution. Distribution. A discrete random variable is the quantitative variable that can take one of the countable list of distinct values. So for example, the number of telephone call you make a week, right? Or the number of insurance you claim per year, right? So things that you can count, things that you can count. For continuous random variable is also a quantitative variable that can take any value in an interval or collection of interval. For example, height. For example, is someone's height, right? Someone height. We can say it's from 0 to infinity, right? So from in the interval between 0 and infinity, you can they can take any value as a certain a particular height can take any values within this interval. Of course, nobody is tall as near infinity, but say between 0 to 2 meters, right? Any random selected person can take a value within that interval, right? Or weight, same thing with weight, right? Same thing with weight. You can take any value in that interval, or times, or time. Here I'm talking about lifetime, right? We're not talking about like negative time, like in physics. Let's take a look at this example here. Categorical, quantitative discrete, or quantitative continuous. A car is selected at random from a used car dealership lot. For each of the following characteristic of the car, decide whether the characteristic is a categorical random variable, a quantitative continuous random variable, or a quantitative discrete random variable. Weight of car in pounds. Is continuous quantitative, right? Because the way of car can take any value within the interval, say from 0 to infinity, right? So this is continuous quantitative. Number of seats, maximum passenger capacity. Can you count? Yes, you can take the value from the countable list, right? So it must be um, discrete random quantitative discrete random variable. So dq is discrete random variable. Overall condition of a car. 1 means good, 2 means very good, 3 is excellent. So 1, 2, 3 here is just a number assigned for the quality of the car. Right? It's not something that you can take the average. Well, you can take the average, but it does not mean anything, right? So this right here, number 3, is certainly categorical. Categorical. Quantitative. Remember what I said before? Length of car in feet. Again, you can take any value within the interval from 0 to infinity for the length of car. So this is continuous quantitative. Finite probability models. What is a finite probability model? A probability model with a finite sample space is called finite. These probability must be a numbers between 0 and 1, and that add to exactly 1. So there are two things here. If you are finite probability models, then the one thing is that each of the probability must be between number 0 and 1. Each of the probabilities within the sample space must be between 0 and 1. And that all of them, all of the probability must be add to exactly 1. So let's try this example below. How many cups of coffee you drink per day? Well, I don't drink coffee, but a lot of people do. Choose an adult age 18 or over in United States at random and ask, how many cups of coffee do you drink on average per day? Call the response X for short. Based on the large sample survey, here is the probability model for the answer you will get. So the first line will be the number of coffee, and the second line is the probability, right? So if you randomly ask a person who 18 and over in US, that person drink no coffee per day will be 36%. If that particular person drink 1 coffee per day, is 26%, and there's a chance 19% that they drink more than 2 coffee per day, 8% 3 coffee per day, etc. Right? So I want to know if this is the finite probability model. The two things, right? So each of the probability must be between what? 0 and 1. And they are, right? 0.36, 0.26, 0.19, 0.08, 0.11. So they all between 0 and 1. Now, are they add up to 1? Let's see. So the second part say you need it to be added up to 1. So 0.36 plus 0.26 plus 0.19 plus 0.08 plus 0.11, and it's indeed equal 1. So yes. So your answer will be yes. It is the finite probability model.